Hello, charming and cheerful cadets. I think you are thought-provoking on the structure of atom. This chapter is base for all the chapters. So let's start today's session. In our previous discussion, we were understanding dual behavior of matter and uncertainty principle given by de Broglie and Heisenberg respectively. Here, let us ask question ourselves. Why can't the momentum and position of an electron be simultaneously determined in the case of Heisenberg statement? Okay, we can only see an object if the size of the object is larger than wavelength of photon used to see it. This is the rule of optics or the physics. Then accordingly, if you send photons and reflected photons give us information regarding motion. Sending photon with lesser wavelength means higher frequency. Higher frequency means higher energy, which disturbs electron, and hence slope of trajectory changes because of a huge change in velocity. Therefore, we can't measure momentum. And if you send low frequency radiation, means it is larger wavelength. When the wavelength is large, that wave nature will hide the object, so we can't see its position. So because of these reasons, it is very difficult to measure and determine the position and the momentum of an electron simultaneously. Only one can be measured with a certainty. That's why uncertainty is there in measuring both at a time. So with this recap, let us start today's session. Today's session is on quantum mechanics, quantum mechanical model, the fourth and the final mechanical model, atomic model of structure of atom chapter given by, let us see, this quantum mechanical model is the most accepted and admired model till now. This is given by Erwin Schrödinger. Schrödinger was a Nobel Prize winning physicist who is responsible for developing a number of fundamental results in quantum theory. See his contribution to the quantum theory. He also wrote on statistical mechanics and thermodynamics, physics of dielectrics, color theory, electrodynamics, general relativity, and cosmology. See what all chapters he has studied, the great scientist. He was awarded the Nobel Prize for Physics in 1933 for his formulation of the Schrödinger equation, which we are going to discuss now. This equation was given by Schrödinger. He said if you take both the characters in account, that is particle character and wave character, we have to define a property that is wave function. Wave function whose waves electronic wave function. So he gave a wonderful equation. It takes a lot of time to derive this equation using the thorough knowledge of higher mathematics. So this is using the differentiation. He has given this equation. Okay. So here he has taken psi, psi, psi. This is called wave function of an electron with respect to x, y, z coordinate. That means electron is located under these three coordinates. Okay, then these are a constant value by taking the help of quantum mechanics help. E equal to h nu. Then m is the mass of electron, E is the energy, V is the potential energy, so total energy. So if you solve this equation, we get the what result of what finding the electron, and this is the simplified form of Schrödinger's equation. H cap psi equal to E psi. This H is called as what? Hamiltonian operator. This is an operator in the mathematics. How we use pH equal to minus log hydrogen ion concentration P. That is operator, like that. there are many operators in the mathematics. So this is one such operator, and it needs a lot of mathematical derivations. Let us not go into that one. Okay, and this is energy of the electron, which is eigenvalue. Now let us see the physical significance of this wave function psi. It gives the amplitude associated with it, but if you do square of it, then it gives the probability of finding the electron in a particular region. See, more than psi, it is the psi square is important. When you go for the psi square, it means it is the answer for the probability of finding electron in a particular region. See, he is using the word region in space. That means quantum mechanical model will tell idea about the electron in the 3D, not in the 2D. Okay, that is the specialty of this theory. Now here we make a new word. Earlier we were understanding about the orbit till now. Now orbit became orbital. It is a three-dimensional space where probability of finding an electron is maximum. One small example. This is the nucleus of an atom. Okay. Now earlier we were saying the electron is here only revolving around the nucleus here only. We were definite. So orbit is a definite path. Now no, because it is having wave character. When it moves in the wave character, then it will move here or here or here, here. So that wave movement is there, no? So it is spending time everywhere around the nucleus. But you see, here are some dots. These dots are what? Here also electron goes. But where it is spending time more around the nucleus in this area only. Okay, in 3D. Please imagine 3D. So the time spent by electron in this area is more than this area. So this area is not taken as the electronic path or the electronic area only because it is spending more time. So this is the shape of the what that orbital around the nucleus. So by seeing the electronic cloud, by seeing the electronic dots, by giving some imaginary line, so we'll come to know the shape of the that orbital where it is spending more time. Now let us go to the salient features of quantum mechanical model. Number one, the energy of electrons in atoms is quantized strictly according to the Bohr's. That means it is energy levels are fixed. Okay, so from one energy level to another energy it can go in 3D in wave nature. Okay, now that is the meaning. The existence of quantized electronic energy levels is a direct result of the wave-like properties of electrons. So because of the wave-like properties, it can jump from one energy level to the other energy level. Only that much amount of energy it will take. That is the meaning. Both the exact position and exact velocity of an electron in an atom cannot be determined simultaneously. This is one of the features of quantum mechanical model given by Heisenberg. This is Heisenberg uncertainty principle as well as one of the salient features. An atomic orbital is the wave function for an electron in an atom. Whenever an electron is described by a wave function, we say that the electron occupies that orbital. That means if you want to know the position and the momentum of electron, we have to solve the equation. Whose equation? Schrodinger's equation. Okay. Then you should go for the psi square. So after doing these two, we will come to know the maximum availability of the electron in that region. That is called orbital of that atom, known as the atomic orbital. So atomic orbital is the probability of finding electron maximum around 90% in that region. The probability of finding an electron at a point within an atom is proportional to psi square at that point. That means more the psi square value, more is the uh, probability. That means probability becomes more. So that means we may go to 92%, 93% like that. So modulus psi square is known as probability density and is always positive. Positive indicates availability of the electron. Negative means what? It is not available. That is the meaning. From the value of modulus psi square at different points around the nucleus within an atom, it is possible to predict the region around the nucleus where electron will most probably be found. Okay, that is called orbital what meaning. In each orbital, the electron has a definite energy. An orbital cannot contain more than two electrons because orbital is very small. Maximum it can take only two electrons, not more than two electrons. But in the multi, this is about a simple structures. When you go to the multi-electron system, that time what happens? The electrons are filled in various orbitals in order of increasing energy. So from nucleus onwards, in the order of increasing, electrons will fill up in the multi-electron system. Now we will go for the comparative between classical mechanics and quantum mechanics. It deals with macroscopic particles. See, bigger one, Earth, planet, all those lorry, bigger one. It deals with macroscopic. Quantum mechanical for the macroscopic, it is the best. It is based on the Newton's law. Newton is the main man who started his classical mechanics. But here, who started Heisenberg along with de Broglie plus Schrodinger's contribution also is there. It is based on the Maxwell's theory, where energy is given or emitted continuously in the form of radiation, wave nature. Here, it is based on the Planck's quantum theory, where we think that energy comes out in the form of discrete value known as the photons, energy packets. Okay, this is particle nature, this is wave nature. Now, the state of system is defined by specifying all the forces acting on the particles as well as their positions and velocities. The future state then can be predicted with certainty. That means here we can easily calculate or determine the speed and the momentum of that macroscopic, because it is a 2D. So it is not moving like a wave. But here, because the particle is moving in the form of wave, so it is very difficult to find the electron at a particular location. That's why he says what? It gives probabilities of finding the particles at various locations in space. So it can give up to 90%. Not or at the most, if you are so correct in identifying the electron, you can go up to 90 to 95%. So that means this is certainty, this is uncertainty, this is definite, this is probable. So I told in the previous topic, we are moving from certainty to uncertainty. We are moving from certainty to probability. So probability of finding electron is maximum in a particular region, that becomes the orbital of that atom. So we are changing orbit to orbital. So till now we discussed about the quantum mechanical model. Now tomorrow onwards, quantum mechanical model also gives some other small topics. So we discuss in our next discussion. Thank you. Thank you very much.